Hurricanes and global warming. Is there a connection?
What impression do you get when you watch this report lead-in from NBC?
As new storms brew in the Atlantic tonight, scientists studying the Earth's climate say we are experiencing stronger hurricanes in this century, a trend that's likely to continue.
The impression NBC gives is that the storms being experienced at the time, back in 2005, were indeed linked to climate change, and they'll get worse. Unfortunately, the scientific paper the news report is based on doesn't exactly say that. And other papers that NBC doesn't mention most emphatically don't say that. So let's look at what the peer-reviewed literature says, because science is advanced through research, and research is written up in respected peer-reviewed journals, not the New York Times or NBC News. Tropical cyclones are called hurricanes in the North Atlantic and typhoons in most of the West Pacific. They get their energy from the warmth of the oceans, so as the oceans get warmer, the number of tropical cyclones increases. A 2008 study suggests that just a half-degree rise in North Atlantic sea surface temperatures would increase the number of hurricanes by around 40%. In his movie An Inconvenient Truth, Al Gore implicated global warming, but it's not that simple. Climatologists say it's likely the increase in hurricanes we saw between 1995 and 2005 is mainly due to a 60 to 80-year natural cycle, not global warming. By the way, this cycle, called the Atlantic Multidecadal Oscillation, may also have contributed to the recent fall in the extent of summer sea ice, but I'll cover that in another video. Secondly, even though global warming will raise sea surface temperatures, that isn't the only factor that influences the formation of hurricanes. Another is the difference in temperature between the sea surface and the upper troposphere. And as global warming continues to warm the upper troposphere, this temperature difference is likely to decrease over the next century. Global warming also increases something called wind shear in the upper troposphere. That's the steepness of change as you cross wind speed contours. And greater wind shear has a habit of chopping off the tops of hurricanes before they get a chance to form. So if the effect of climate change is to decrease temperature differences and increase wind shear, doesn't that mean that increased global warming would lead to fewer hurricanes, not more? Well, yes. That was first postulated in a 1998 paper published in the Bulletin of the American Meteorological Society. The researchers tentatively concluded that a doubling of carbon dioxide levels in the atmosphere would probably not lead to more tropical cyclones on a global scale. The very modest available evidence points to an expectation of little or no change in global frequency. Over the next 10 years, that modest evidence was added to substantially. In 2010, a definitive review of all the research and the data was undertaken by an expert panel and published in Nature Geoscience. Their report projected an 18% decline in the number of tropical cyclones by the end of the century and a 30% decline in the number reaching land. But there's a twist in the tale. While normal hurricanes would fail to form because of contrary atmospheric conditions, these wouldn't be able to stop the strongest hurricanes from forming, and because sea surface temperatures will be higher in future, these strong hurricanes will be exceptionally strong. So the same research papers conclude that while overall the number of hurricanes will decline, those that do occur will be especially strong. The Nature Geoscience paper estimated that the wind speed of hurricanes would probably increase 2 to 11% by the end of the century. That may not sound like much, but a study by Emmanuel concluded that a 10% increase in wind speed translates to roughly a 60% increase in damage. The next question facing researchers is, has this process already begun? Are we already seeing stronger hurricanes because of climate change? A 2005 study published in Science found a large increase in the number and proportion of Category 4 and 5 tropical cyclones worldwide since 1970. That same year, a paper published in Nature reached the same conclusion. A 2006 study analyzed the cause of sea surface temperatures and found strong evidence that global warming is a factor. But it's impossible to discern with certainty how much current hurricane intensity might be due to global warming and how much is the result of natural variability. One thing all researchers agree on is that the length of the record is too short and the evidence too ambiguous to reach a firm conclusion. If this all sounds a bit complicated and messy, let me try to summarize. This is what most climatologists now agree on. There'll be fewer tropical cyclones because of global warming, but those storms that do make landfall will be more powerful. so there'll be more strong storms. We're currently in a phase of heightened hurricane activity because of a natural 60 to 80 year cycle that began around 1995. And here's the main area of uncertainty. There is evidence to suggest that recent hurricanes may have been stronger because of global warming, but this isn't conclusive. As I said at the start of this video, uncertainties like this don't make good headlines, and linking Hurricane Katrina to global warming, as some media did after the devastation of New Orleans, is speculative claptrap. But media outlets trying to debunk climate science also misunderstand the link, sometimes with laughable results. Here's Britt Hume trying to show that hurricane activity has decreased.
The Northern Hemisphere is actually experiencing near-historic inactivity so far in 2007.
Without realizing that this is exactly what climate scientists say should happen due to global warming.
Some global warming alarmists, you remember, issued predictions of an era of stronger and more frequent hurricanes following the devastating storms of 2005.
But the warnings about more frequent hurricanes were related to a natural cycle, not global warming. By twisting the figures to claim that we're seeing fewer hurricanes, Hume is debunking the natural cycle and suggesting that the effects predicted for global warming are already upon us. Has Fox News come under new management, or are its journalists so scientifically illiterate that they automatically try to undermine any scientific research and not recognize when it actually supports their editorial position? And Fox News wasn't the only one to get this hopelessly wrong. If conspiracy theorists read the scientific journals instead of internet chit-chat, they'd know that most research papers do not say that global warming equals more hurricanes. And we can't take the opposite extreme and say that because we have a few years of fewer hurricanes, that must be the effect of global warming. None of the models suggest that either. Let's move on to another popular assertion about the consequences of climate change.
Tuvalu, only 16 feet above sea level at its highest point, is now in danger of becoming a modern-day Atlantis.
There's fear that the area could disappear within 50 years if action isn't taken over climate change.
The image we get from the media is that low-lying atolls are going to be drowned under rising seas, disappear, a modern-day Atlantis. Apart from polar bears on icebergs, the precariously low-lying islands of the South Pacific are the poster children for global warming. But there's no evidence these islands are going to be inundated, and what we know about how they form suggests they're more likely to do the opposite, grow bigger. To understand this, you have to think about how these islands formed in the first place. We're not talking here about continental islands, which are off-lying peaks separated from the mainland by rising sea levels at the end of the last ice age. True oceanic islands were created by volcanic activity in the middle of oceanic plates. But if many of these volcanoes eroded and disappeared millions of years ago, why are the islands still here? The answer is that the coral fringe around them is alive and growing. Dead coral, either broken off by wave action or marine organisms, builds up to form an island, and it's still building these islands today. This isn't exactly news. The process was first postulated by Charles Darwin, and a number of papers have been published over the decades documenting the continuing growth of these islands. Although research continues, there's as yet little evidence that the expected rate of sea level rise will reverse that. In 2010, Arthur Webb and Paul Kench analysed hundreds of historical aerial photographs and confirmed that 23 out of 27 Pacific atolls are indeed either stable or growing in size, including Tuvalu. So why do climate scientists insist that these islands face problems? Well, the problems are related to other issues caused by climate change, such as storm surges, coastal erosion and saline intrusion, not total submergence from rising seas. But of course, the stability of the islands depends on the continuing health of the coral reefs, which brings us on to this.
What happens is that the tropical waters where they live are getting too warm, and when they get warm, the corals actually purge. They literally blow out the zooxanthellae, and when that happens, they go from vibrant purples, greens, and reds to sort of dull oranges and whites. The corals actually die.
The real story of coral and global warming is a bit like the game of good news, bad news. And the bad news, of course, is that there's no doubt that warmer waters can damage coral. Corals survive by forming a symbiotic relationship with algae, which feed them. When average water temperatures increase by around 1 degree centigrade, the algae become unproductive and are expelled. This leaves the coral looking white and dead, a process known as bleaching. But it doesn't mean the coral is dead. It can recover as temperatures cool again. Well, that's the good news. The bad news is that several years of above-average temperatures make this bleaching permanent, and this has happened in parts of the Indian Ocean. Is there anything the coral can do to adapt? Well, one possibility is that they can change the type of algae they cohabit with to a type that will survive higher temperatures. In 2006, a study found that very few coral species can do this, but the methodology and the data used to get this result were questioned the following year by two other researchers. They concluded that a lot of coral species could change the type of algae they employ, so if they're right, we can chalk that up to good news. Even if coral do successfully switch to more heat-tolerant algae, known as type D, these can only survive temperatures up to 1.5 degrees higher. If water temperatures go any higher than that, researchers say no suitable algae can survive. Good news? Well, coral may indeed die out where they stand today, but they could grow instead in higher latitudes. What's the evidence? Well, about 6,000 years ago, the sea around Tokyo was 1.2 to 1.7 degrees warmer than it is today, and coral flourished. The bad news is that that success might not be replicated in the future. According to a report by the Pew Center, human activity in many coastal areas is now intense, and pollution and other factors may prevent coral from easily forming. But there's an even bigger reason, the fact that nullifies a lot of the good news about coral. It might be able to cope with the temperature of the water. What it may not be able to fight is rising acidity, as increasing carbon dioxide in the atmosphere dissolves in the oceans to form carbonic acid, and acid eats away the calcite shells in marine organisms, including coral. But a study from Stanford University found that corals will only be affected when carbon dioxide levels reach 550 parts per million. That's expected to happen in 2050. Carbon dioxide dissolves better in colder water, so cold oceans are feeling the effects first. I'll look at that in a later video. To be honest, on the whole, most media don't do a bad job in reporting the science. Sometimes they do get it wrong quite spectacularly. Often, newspaper headlines and 2-minute TV news stories don't have room to report the complexities reflected in the science journals. The problem is, critics confuse these headlines with real science, so when inaccurate and hyped stories in the media are shown to be wrong, it's assumed that the science was wrong. Anyone who's watched my video series from the beginning knows it's a familiar pattern.